Hello everyone, my name is Gilbert and this is Internet Explorer 9 Performance Tricks. Welcome. This presentation is part of a 4-series webcast where we're going to be talking about Internet Explorer 9 and all the new tools and features that Microsoft has put together for us developers and designers in this new browser. This is the second take to this webcast. On the first part we talk about walk around Internet Explorer 9 and the basic features around it. Today we're going to be focusing on performance tricks that all of us can put in practice in our designs and our developments so that our applications will perform better and faster. And at the same time, following this presentation, we're going to be talking about how you can blend your site with Windows 7 and how you can bring all of these features that Microsoft put together in Windows 7 applications, and then how you can take advantage on your website so that they behave a little bit closer to applications. And at the end, we're going to be talking about how you can take your website to mobile and how you can take advantage of Internet Explorer 9 on Windows Phone 7 on the Mega version. So let's start. With Internet Explorer 9, Microsoft put together a set of objectives that they wanted to accomplish with this new release. We can group these new objectives in 3 sets. The first one, interoperable HTML5 markup. That means your code, your markup, your CSS is going to run the same way in Internet Explorer 9 that it does in other modern browsers. That means that from now on you will only need to keep one code baseline in order to move forward with new features and new capabilities for your users and in your web applications and websites. That means also that you from now on will not have to be worried about finding workarounds to limitations that previous browsers had, and therefore focusing on adding value. The second set is focused on GPU-powered HTML5 graphics and media. That means that Internet Explorer 9 is going to take advantage of all the power available in your computer to improve the user experience. That means that all of the rendering is going to be happening at a graphic processor level and not on the CPU as most of the browsers does today. And third, we're going to be focusing in across-the-board high-performance HTML, and this we can point it out in JavaScript execution through a new JavaScript engine called Chakra on an improved page layout and improved page display, and this thanks to all of these hardware enhancement capabilities. And this is where we're going to be focusing today, in some of best practices that you can put into play in your websites, in your web applications to make the most of the platform available today. So before we go there, how much do you know about performance? We need to start learning how to read tea leaves. We need to learn how things have evolved during the last several years. So here we have 5 of the most important newspaper websites in the world and how they behave. We've done certain analysis and then we can start understanding the way the browser works. So let's take a look at some of the analytics that we have gathered. So here we have in terms of total size of download for each one of them. So here we can see that we go from 400k all the way to 1800. At the same time, we can see that there is some changes in the number of elements, and there as well we go from 800 all the way to 2000 elements per page. In terms of CSS rules, we see some variance there. We can go from 500 or almost 600 to 3100, and that's a big change. And that also means that there is going to be some impact in terms of rendering. In terms of image files, there is some not that much difference. There is one that is probably double than the rest, but all of them keep it low. Then we have some script blocks and script lines, which also has some difference all the way from 9,000 to 27,000. And then the script frameworks that they use. Here we have found that they used things from jQuery to Yahoo UI, Prototype, MooTools, and Scriptolicious, but they also use some sort of homegrown script framework. And we're going to see the impact that that has in terms of the time. So which paper loads faster? Which one do you think? Might be the one with small size or the one with bigger size. So here we see that the small size in terms of fast doesn't have anything to do. If we take a look at this one, we see that it's not only the smaller one, because we have here this one on 400k in size, and it's also not the one with less JavaScript lines, because in this case, is second to the first one with 10,000 lines. But what we can see is that the number of elements across the line is lower than the rest. And here CSS rules take a hit. In this case, they're making use of fewer CSS rules than most of the rest. But at the same time, their way they have built the application pays a big deal on this. Here they're using the Yahoo UI and they have their own screen framework, but it also means that some of that performance that is gone through these frameworks is they're also taking advantage in their own execution. If we see which one is the slowest, we'll see that in this case is the one with the smaller number of elements in the page. Also, it's not the smaller or the biggest one in terms of size in K and not in the script line. So we see this one is third to the size of lines in terms of a script. But this one doesn't use any line of code from the community itself in terms of a framework. This one is all homegrown. That means also that the amount of capability that they can put together in terms of tuning is limited to the one that the whole community can put together in such frameworks. That means that it's gonna be slower, that the code that it holds is probably of less performance than other ones that have been tuned up by the community. So instead of thinking about those things, let's understand how the browser execution go and where all this time goes. Internet Explorer 9 has 11 subsystems in it. Each one of them has a certain responsibility for the overall life cycle of the page. So we start here from networking. Networking will be responsible for all of the fetching and sending of requests through the line. Then we have the HTML, CSS, and JavaScript components that are going to be taking those assets downloaded by the networking and putting it together. In the case, we're going to be building some collection. At the same time, we're going to be building the data object model. The marshalling component is going to take advantage or is going to be responsible for all the communication across the systems, therefore handling all the communication and making things available when needed. We also have the formatting, the block building, and the layout subsystems. In this case, the formatting is going to take all of that CSS and the DOM and put it together into blocks. And blocks are going to be the different building blocks that are going to make up the page and all the different C indexes to that, and so that the layout is going to know what is it that is going to be rendered at the end. And then we have the rendering, which is the one responsible for drawing things on the screen and basically is the end part of the pipeline. So if we take a look at how the page load times is divided by subsystems in all of these 5 newspapers, we can see there are 3 subsystems that take the most of the heat, and this one is the rendering engine, the JavaScript part, and also the layout subsystem. That means that this is where we should be focusing a lot of our work in terms of tuning up the experiences. And if we put this on an average distribution, we'll see that those 3 are pretty much consistent through all the different pages or websites. And we see the rendering taking the big part here. We have JavaScript taking second, and then we have layout taking third. And then with this, we will be looking at how all of this impact goes in terms of making our pages better. Now let's take a look at how different this goes with sites that are mostly powered by Ajax technology or Ajax model. And here we see that the layout takes a bigger chunk than the previous one, and this is because the JavaScript is going to be making a lot of changes to the DOM, and that will result into the layout being fired up so that we can re-render all of those elements. That means that we should be able to improve this experience by batching up changes to the DOM and by making this in one single call rather than just making calls in different portions of our JavaScripts, so that in this way we can improve the change. We can just make it once, make it render, and then instead of making several small chunks of changes that is going to impact and is going to require the layout to re-render several times just for one change. So all of these questions were asked by the team. Where and what do we tune? That means we cannot put all of the resources into improving everything at once. We need to prioritize. So for that, we go one step backwards, and then we focus on Internet Explorer 8 and how the processor utilization happened. With Internet Explorer 8, most of the work happened in the one core, and here we have most of the work happening there. And then after some time, there will be some task happening in here, some of the JavaScript execution. But with the new JavaScript interpreted in IE9, things change a little bit. On the first code, we have things just as usual. We have the source code, which is fed to the parser, and after that, an abstract syntax tree is built, which eventually is going to be turned into bytecode, and that bytecode is what the interpreter is going to be utilizing to execute. On the second core now, we're going to be having some background compilation happening. So that bytecode, we're going to be learning from how we execute that throughout time, and then we're going to be able to compile those parts that are most important to the execution of the page. That means that we're not going to compile everything, we're just going to compile certain portions that take the hit in terms of performance. And that compilation is going to end up in native code that is going to be fed to the interpreter, and therefore is going to be improved in the way it executes. So that means that throughout time we're going to be learning, we're going to be taking some of that knowledge that we built in terms of creating this bytecode and then knowing which portions are worth compiling. That also means that throughout time, and this doesn't mean in the same session, that means also that we're going to be learning session after session how the web applications that you mostly visit uses JavaScript. So if we see the Internet Explorer 9 process utilizations, we're going to see that there, after some warm-up time, the background compilation start working, and some of this work goes into analyzing the code that is being executed on the first core, but also into compiling that code into native code and therefore improving the execution. And then we see that after some time, most of the code that can be compiled will be compiled, and after that the execution continues and the JavaScript hit is reduced exponentially. So we see that this is a big improvement in terms of execution, in terms of performance, that all of the applications that you write and have already written are going to take advantage for free. So let's take a look at the Internet Explorer 9 JavaScript integration. For the first time, JavaScript is a first-class browser language, and we're going to see why. In Internet Explorer 8 and previous versions, JavaScript was a component of the operative system, something that the browser will communicate using COM. The same will go for the BB script. So the JavaScript will have its own implementation of the DOM, just like the browser, and it's going to be communicating to DOM in terms of making things happen. That not only added a lot of marshalling time here in between, but also meant that the Internet Explorer team was not in control of the JavaScript engine. Now let's see how Internet Explorer 9 behaves. We have the BB script as well outside, and this will keep going as COM. This because it is not that much standard to use BB script as part of your website, but if you do, then you can still using it under this scenario. But in terms of JavaScript, which is the power nowadays of most of web applications and websites available on the web, the JavaScript is part of the Internet Explorer. And here with Chakra, which is the name of the new engine, things have changed radically in terms of performance, in terms of tune-up. There has been a lot of code analysis going on here, and now is part of this. That means that the DOM is shared between the browser and the JavaScript, and that means that the access, it's pretty much native into the execution. We're not going through any heavy load marshalling to get there. Now there is also a change in terms of rendering, and here we were saying how all of the capacity of your EPU is going into powering the graphics. If we take a look at how CPUs versus the GPU has accelerated along the time in terms of gigaflops across the time, we see that the growth in the GPU has been exponentially. The advancement in technology has been great if we compare to the CPU that has been growing slowly across the time during the last decade. That also means that the GPUs nowadays is not just for games, but also to do other things. So if we take a look at traditional browser approach to graphics, all of the images and text is going to go to the CPU, and from there it's going to go to the GPU, and then from there to the screen. Now with Internet Explorer 9, what we're going to do is that we're going to take advantage of all the power of DirectX, Direct2D, and DirectWrite, part of the Windows 7 subsystem, and what we're going to do is that we're going to be passing all of that to the GPU directly. So that means that we're going to leave the CPU for other tasks, specific tasks, and for other software of other applications running on our computer, meaning that Internet Explorer 9 is a better citizen than previous versions in terms of resource allocation. So that means that images, text, video, SVG, and Canvas are all going to be hardware accelerated from now on, instead of going through the CPU. So with all these said, and with all this kind of context that we put together in terms of how things work inside of Internet Explorer 9, let's take a look at how some best practices can improve the way your web applications and website behave with little effort. So let's take a look. We're going to be dividing these performance principles in 6 main points of attention. The number one is quickly responding to network requests. We're going to see what kind of things we can do in order to minimize some of these requests. Also, we're going to be looking at minimizing the bytes downloaded, and this we're going to see it through some tricks that we can do in terms of improving that. Also, efficiently structure your static markup means that the markup that you write is going to be consciously done in terms of simplified and well done. On the number 4, we have the optimization of media usage. Number 5, writing fast JavaScript, and we're going to give you some tips there how to improve some of the work that you do. And then number 6 is knowing what your application is doing, and here we're going to be doing some call attention to things that most of us should be doing with our apps and with our websites. So let's start with principle number 1, quickly responding to network requests. That means rule number 1, avoid redirection. That means that we should not redirect our request to other pages, either to 303 response or through any other one. We also have some of those refresh tags that we put on our pages that shows you on the browser this page is gonna redirect after 5, 4, 3, 2, 1. All of that time is a waste on resources. It's also a waste in terms of the bytes that are being download. It's a waste on your bandwidth. So all of this should be avoided, and instead of that, after the request, you should be handling those things on the server and serving content right away after the request. That also means that you should minimize server time for requests. That means that you should respond quickly to those. So when the browser hits the web server, there are things that are happening. You go to the user database, you go handling some business information, but you have to reduce those. Use cache. Make sure that you use some of the technologies available today in order to minimize those hits, and so that you can respond quickly to the server. Another tip on this is using CDNs, or content distribution networks. This means that instead of going from one site to the other ones, there are going to be some clouds in between that can host content for you, in either to the where the user is located. So you're not going to be going all the way through your server, but are going to be going nearer to the user, so that those resources are going to be available prompt and quickly for them to download. That also means that you can maximize concurrent connections. So with Internet Explorer 9, you can have up to 6 concurrent connections to the same domain. But if you make use of CDNs, or content distribution network, that means that you can have several domains. And for those domains, you can also have 6 other concurrent connections. That means that if you host your images separately from where you host your JavaScript and your content, the browser will be able to take advantage of all the concurrent connections in order to get those and download those to your client faster. So that means better and improved experience for the users. Also, another tip, reuse connections. That means that instead of closing a connection and then doing all the marshalling and doing all of the head checking that goes per every request, you can keep that connection open with the server, and therefore making all of the communication faster. And thankfully, all of the modern web servers have support for this. Now, you have to be careful for something. There are some Apache configurations that keep this as part of their config file. None keep alive and the SSL on clean shutdown. This means that for any user agent that is Internet Explorer, node connections are going to be kept alive, especially SSLs, which are very expensive to open. And the reason for this is to counterpart a bug with IE 5.5. So that means if you have to support Internet Explorer 5.5, you should keep this, but if not, you should remove this, because this is making your connections happening a lot slower than they should, and the responses going back to the client are a lot slower due to all of this overhead work that is happening. Principle number 2, minimize bytes downloaded. This is saving your bandwidth, but also saving the time that it takes to render the page on the client. For that, compress your network traffic in order to improve the use of the resources available. And for this to happen, when the request is done, the browser adds some meta information about the things that it supports. And one of that is the accept encoding. And part of that is encoding, there will be the gzip part of it. That means that the response of the web server can take advantage of that, compress the content, and then send it as a gzip, which is going to be fast, decompressed on the client, and provided to the user. Therefore, you're saving your own bandwidth, but you're also saving time in the user location in terms of rendering. The other one, provide cacheable content. Here we were talking about CDNs, but also in terms of the way you serve images or content. So here we have some requests for an image, and we send a response back with an expiration date, and we say this image is gonna be fine up until a certain point in the future. That also works for conditional requests. We can send as part of the response when was the last time the resource was modified, and in the request we can say if the resource has been modified right after this date, which is the date that he has, then send it back. If not, then just let me know when was that time of last modification. Therefore, we can hold of that content in the cache and then respond back with a 304 that resource has not been modified, therefore using the content that we have locally on the client. Next is caching the data request in the browser. That means that whenever we do data request to the server, we can cache that data, especially that works for things like catalogs and things that we're going to end up putting in combo boxes that will not change over all time. So we can take advantage of that. And one of the great things is that jQuery already uses that by default. We either not pass that information as part of the request, and jQuery is going to cache that data for some time, or we can disable that for requests that we know are going to change rapidly along the time. Therefore, we're going to be able to maximize the data that we use in terms of using it right from the local client and not making the request back to the server. Also, it means that we'll be able to respond quickly to either building the UI or whatever we need the data for. And last for this section is standardizing on file capitalization. That means, especially for images that we're going to be reusing across different pages, we want to make sure that we state for one type of capitalization, whether it be all lowercase, whether we use title case, or for those careless developers that are going to be using things like the one that we have down here, and we're going to be having different types of capitalizations across files. That means the browser will always make a request to the server for that file, and the server is going to take time as it resolves the name, and it's going to say the browser is going to save it as two different assets. So better make sure that you keep those images all named the same in your web pages. Therefore, we can utilize all of the things that we have talked before about conditioning and caching of the assets. Now let's move to principle number 3. So here we have the efficiently structure of your static markup, and this is where we're going to focus next. You have to make sure that whenever you're writing your code, whenever you're serving your code, you pretty much make use of the latest browser mode, especially Internet Explorer, where with Internet Explorer 8, the team introduced what is called like the browser mode, and then you can use either the IE8 mode, the IE7 mode, which is using the IE7 layout engine, or the Quirks mode, which is a legacy IE and especially works for websites that were designed or built with IE6 in mind. So make sure that you code against the latest browser mode, and in Internet Explorer 9 that means HTML5. So from now on, start moving to doctype HTML, which means it's HTML5, and don't bother on putting the standards mode. It means that you're gonna be working on standards. With IE9, we're making sure, and this is, remember, this is part of the objectives that the team had with the browser, that your code is interoperable between browsers. That means that when the team was testing out the layout, it meant that they were comparing with all modern browsers of age, and they were making sure that your code was gonna work the same way. On that, if you have to use browser modes as part of your content, don't do it as part of your meta tag, do it as part of your HTTP header, because that means that the browser will be able to prepare itself for that engine beforehand that they start doing parsing of the content. If you put it on the meta tag, it means that the browser will go through the parsing of the content, and it's once it finds the meta tag that it's going to change layout engine. So if you put it as part of your HTTP header, it means that as part of the networking process, it's going to understand that he has to render the code in a different mode, and therefore do that preemptively before the parsing even starts. So the other thing, and especially in terms of linking to assets, link is style sheets at the top of the page, just as high as you can. Why? Well, because this is part of how the parser works. It's top down, so as soon as it finds the links, it's gonna go and fetch those resources. So you want to do that right up front, so that the process of building up the CSS trees is gonna start in parallel as soon as possible, because it takes time. So you want to do it as much in the top as you want, and never link those styles on the bottom. Why? Because it's gonna be building the DOM, it's gonna be building the building blocks, it's gonna be building the formatting, and it's gonna be doing that all in parallel. And if it goes up to till the end, especially if the page is big and starts streaming the content, then it's gonna have to do the whole process all over again. So make sure that you do it on the top of the page, so that all the process can be parallelized as much as possible. Avoid using import on your style sheet so that you do hierarchical styles, because all of these are going to result in more HTTP requests. You want to do as few HTTP requests as you can, so that you can maximize the number of parallel connections or concurrent connections. So make sure that you don't use import, and rather have the files with the content and the rules needed. And that also means avoiding embedded and inline styles, because the browser won't be able to either cache that content or have some of the pre-built of those rules, and that means that it's gonna have to do several changes and several iterations to the styling and to the building of the CSS structures. Also, only include necessary styles, so don't include styles that are for content that are away from the page, or the things that you're going to be using at the page. So you have to be very careful in the way that you structure your CSS, and make sure that what you add is what you need. And you may be wondering why. Well, the reason is that everything that you put there is going to end up in some internal structure within the browser, and it's going to hold that in memory, and it's going to hold that as part of the whole building of the process. So the less the better. Just put what you need. Make sure that what you're putting there is things that you're going to be needing in the exact scenario where the page is going to be rendering. Therefore, there's not going to be elements that are not needed, that it's just taking space and also making things more difficult in terms of crawling the structures or for finding different scenarios, and also doing the mixing. Moving along, we have principle number 4, optimizing media usage, and here we're going to be talking about image formats, videos, and such. Image formats up to date has been very scarce, and we have been through all the history of internet, being moving along from GIF to TIFFs to BMPs, and now to JPEGs and PNGs. All of these scenarios have been increasing across time, especially in terms of the resolution of images and the size of the image, or the compression of the image. So try to use standard images. In terms of what we're talking is like PNG by default for website elements and logos. Try to use JPEG for photographs, or things that need a lot of pixel density and has a lot of resolutions. Try to use JPEG XR for high resolution photographs. But don't get distracted by GIF and TIFF and BMPs and other formats, because modern browsers and modern computers are not tuned for these kind of formats. These are formats that are supported as a legacy or for very special cases. But for most of the big part of all of your assets and your pages, you want to stick to PNG and JPEG. PNG and JPEG are, some of them are hardware decoded, some of them, their implementations are very fine-tuned up to until now, and it's gonna make your pages render very quickly. That also means that they're gonna be able to take hardware acceleration as part of the process, meaning sending a lot of this quickly to the rendering pipeline. Also, try to use native image resolutions. Don't try to have the browser scale down your images, because that also means that it's going to be taking time into the process of rendering the page. So make sure that you do all this processing ahead, and therefore when the image gets to the client, it's already prepared and scaled to the size that is going to be needed. It's better that you have done this ahead of time on your own, spend 5 minutes doing this, rather than having all of your clients, all of your users doing this every time they hit the page. So try to do this. These are milliseconds that are count up until the end process. Also, try to optimize the amount of images that you serve. Avoid the death by 1,000 images. Don't send images for every single thing that you imagine. Just pick the ones that you need and then just send those, right? Don't add things just to be cool, but actually to add value. And also, rather than doing all of these images in all different sections and having 1,000 images being sent, try to use image sprites for the ones that you're going to use. So image sprites means getting your images all in one file and then using the background accommodation of in CSS to get to the image part that you want, so that you can somehow pan the viewport around the image and then focus on the image that you want. So here we have an example. In scenario 1, we have multiple files. So here we have 6 images, 40 by 40, 6 connections. That means that we're maxing out the number of concurrent connections, and that also means that we're downloading 96K from the server. If we put all of this together in one single image, like the one in here as a sprite, we will have only one image of 40 by 240 pixels. It's going to mean that we're going to be using only one connection, and we're going to be downloading only 21K. That's a reduction almost of 3 times or more than 3 times less than what we're downloading here. And here we're only using one connection. Here we're maxing out all of the concurrent connections that we can do to a domain. So some of these things are very important in terms of maximizing not only the connection but also maximizing the download that you're doing. But when doing this, and this is a tip that we're giving you guys, try to do it yourselves. Don't try to use one of those programs that you can find offline that is gonna put or stitch all of your images together. Why? Because they are not smart, they're not intelligent as you are. Because you can see that there is a lot of white space lost in here. This is just a best approach to accommodate images based on whatever algorithm they use. But nothing is gonna be better than you sitting in front of your computer and your eyes and finding the right accommodation for images. Also, these applications are not smart enough to find out that you have 2 of the same images on the sprite, meaning that you can do without this logo and then just with one logo and then just moving along with that and reuse it. So try to do it yourself. Don't trust services or whatever that will stitch the images for you, and you're gonna be fine with the process and you're gonna be maximizing a lot of this. Other ones, replace images with CSS3 gradients. CSS3, it's getting better and better with the day, and there's a lot of powerful tools that you can do with this. So pretty much try to start making the jump into features that uses CSS3 capabilities or adding those to your website. So rather than using this, try to use gradients. Why? Because this is going to be processed as an image, especially if it has some sort of opacity to it or some sort of transparency to it. Try to use the browser's implementations because they are gonna be better implemented. They're going to be fine-tuned to the scenarios rather than just doing some imaging blending process that is going to take more time. And the way it's implemented, and this is because of the standards, also changes. So make sure that you try to use as much of native implementations as you can, and then just for some specific scenarios, then you can go with hacks like imaging. The same goes with border radius. Before CSS3, all of the implementations for border radius were basically image based. We will take an image, we'll split it in the different parts that we'll do, and then we will implement it through divs or tables. But nowadays it's pretty much supporting all modern browsers, so make sure that you take advantage of those. And then just like with gradients, you can reuse those across your site, and you're going to be doing natively. And the implementation is going to be smooth and fast as you want. Other one, try to embed small images to data URIs. This is a new way that you can embed pretty much base64 encoded images into your data as a data source into your source. So for small images, that means that you can put it as part of your page. You're not going to be doing more requests to the server, and it's going to work just as great. It's just what the browser is going to do is just take this source and then just create an image out of it, just like you would do if you would be downloading the image. So again, this is in order to maximize connections, maximize the data download. The best that you can do is having less connections to your server. So not only is a hit less to your server, but also it improves the way it implements. Also try to use SVG. So Internet Explorer 9 has great support for SVGs, the whole center. So for certain images, especially vector-based images, try to use SVGs as much as you can, so that these will replace layer images. So instead of downloading a big image, then you can reconstruct that very efficiently in the client. Now, this comes with a caveat, and then that is try to avoid complex SVG paths, because this again is going to take a lot of computational time. So this have to be a balance, whether you go with one or the other one. But if you're going to be passing along a huge SVG with huge complex SVG paths in it, then try to go to the image. You have to be clever here. How do you go? If the image is too big but it's quite simple, try to go with SVG. If you can do a balance and the image is not that big and the computational power that it's going to take to render or to generate the image is going to be higher, then go with the image. But the rule of thumb would be, if it is simple enough, go with SVG. If not, then think of some other scenario that will fit. With video, and this is improving the user experience and at the same time the way the images and the videos loads, try to use user preview images. And this works both for HTML5 and other situations. Therefore, the browser will defer the rendering of the video up until it's needed. So if you put an image, it will improve the user experience because the user is going to have something there to see. And then you can make the move either to HTML5, video, or whatever other mean you're doing to play those. Going back to CSS3, try to use transforms as much as you can. Take advantage of that, especially for animations. You can do that. As I said, most of browsers use it or support it. So these are some of the elements that you can take advantage of. And another tip that we can give you is try to proactively download your next resource. We have here in the case Bing. You know, Bing have these beautiful images that it changes every day. Well, guess what? Bing downloads tomorrow's images ahead of time. That way, when you hit Bing next day, the images just load. It's already in the cache. It's already there waiting for you to be served. So try to do that as much as you can. Go one step further from your clients or from your users and know what they're going to need next, or what they most likely are going to use next, and then go get it. That way, when they're going to look for it, it's just going to be there. So this is some tricks that even though you're using some of the bandwidth today, the user experience is going to be improved dramatically in terms of responding to changes. So now let's move. We're going to the end, but let's take a look at what you can do in JavaScript. I know that all of this presentation is being very high in content, but all of these are things that you can put in practice very quickly with not that much effort, but it's gonna make a change dramatically to the way the user experience your website and also in the way it behaves with your server. You're improving the capacity that you have, and while at the same time improving the user experience on the client. In terms of JavaScript, opposite to what we talk about CSS, with JavaScript there is this special case where we're gonna be avoiding linking JavaScript in the head and rather put it as low as we can in the body. Why? I'm gonna tell you next. The body, and here we go, same with inline JavaScript. The way the browser performed this is that JavaScript is an interpreted top-down language, and a lot of uses for JavaScript is to generating HTML and doing changes to the DOM. So the way the browser is going to go with this is that every time it finds some JavaScript, whether it be this a script file or inline script, it's going to stop the process of building the DOM and it's going to execute the code. Whether this code ends up being put as generated code in the DOM or not, it's going to do this because he knows that the chances that the JavaScript is going to change the DOM are high. So it's not going to come finishing that process until the JavaScript is parsed, executed, and all interpreted. So make sure that you send those to the end so that the browser can create the DOM, parse the DOM, create all of the different structures, and then focus on the JavaScript as it can. So as I said, link the files towards the end of your body. Wait for that to happen. Let the browser take advantage of all of the capability that it can to build fast the DOM and all of the formatting and those things, and then let the script modify those if that's what it needed. Or, on the other case, just let it be prepared to react to those changes. Now, if you cannot put the script on the end, and these are some specific scripts that needs to be placed on the head, then try to defer this processing. That means that what you're saying is, don't do it now, do it until the end. Go, keep on doing what you're doing, and then come back to me when it's time. So this way, you're going to improve dramatically the way your pages are parsed, and also you're going to be improving the way the JavaScript is done. Also, try to remove duplicate code. Sometimes we're careless and then we have sometimes the same script imported twice. So try to make sure that you go and revisit your pages script imports so that you make sure that nothing repeated is there. Also, try to standardize to a single framework. Don't keep adding all of the different frameworks just because you need a feature or you find something online that is built on top of one. Try to standardize to one and then try to make all of the different implementations of things that you need based on that framework. Because a lot of these frameworks, they either overlap in themselves, they rewrite themselves on top of them, there are features that you cannot oversee, and the big part, these frameworks, most of them are big and they are a hit to JavaScript. They do a lot of stuff for you. All of them, most of them focus on very similar things. So try to make sure that you understand what you're doing and only add those that you extremely need. Try to do, extend your homework, and then, if you're trying to look for a slideshow or for a gallery that is built on prototype, but what your website is doing is using jQuery, try to look further. There are tons of plugins, tons of implementations in all of these different frameworks that the chances that you're going to find what you need are very high. So just extend your homework, and before you adding another framework, try to extend your possibilities in seeing if you can find something implemented in the framework that you're using already. And also, following that, don't include things just to be cool, especially if you're adding all of the different Facebook plugins, all of the different Twitter plugins, all of the different analytics. Stick to one, make sure that it works well, and then provide value. At the end of the day, what you want to do is provide the right value to your users and not just overcomplicate things, especially when you don't own those scripts. You don't never know what those things are doing in the back, and you don't want them to be a hit on your experience. Now we have some things here. Try to minimize your JavaScript or minify your JavaScript, especially in terms of characters. there are a lot of things that we can be doing in terms of removing blank space, removing the naming, so changing the naming to, instead of number 1, number 2 to n1 and n2. Try to use obfuscators for doing that. Sometimes we write this kind of code because it's easier for us to read, but the browser doesn't care if it is well or nicely written or not. So write the code the way you would like it to be read, but then try to use some tools either to obfuscate your code, therefore changing the name of the functions and the name of the variables to things that are gonna be better fit in terms of minimizing characters. So just a simple example, here we have a function, here we remove all of the blank spaces in it, and pretty much behave the same. We're between this one and this one, we're pretty much reducing all the blank spaces in 12 characters. So that counts for something. Those are 12 different bytes that we're not sending over the wire, so make sure that you can take advantage of those. Also, like I was saying, naming is important. So instead of having number 1, number 2, those are big numbers. So try to use A and B, or 1 character variables. This, again, you can do it either in your code or have other applications or other tools do this for you so that it will minimize your code. Yahoo has one that works great, so try to use those to obfuscate it. And that same also, you're protecting your code so that not is gonna be copied by somebody else, and therefore improving security there. Inlining, so if you have one function that calls another function, then if that is the only thing and the other function is very simple, the other thing that it's going to do is just carry on that functionality and then you sum it up in one. So here we have an example here, this one, which is a function that calls another function. The other function, the only thing that does is call back, and this is some kind of like recursive implementation. So just simplify it and then just use one single implementation of a function. This also means that we're going to be removing the characters, but also simplifying the process. And this is going to be the jump stack that is going to have to go through when returning back to the client. So also improving that, it makes your functionality very fast. Then, and this is part of what I was saying before in terms of how you load your content and how you load your JavaScript. We are used to be using the load event to execute a lot of the code that we use on the JavaScript. But this might not be the most efficient way to do it. You want to start doing all of your changes to the DOM right in the moment when the DOM content is loaded, and not when all the page is loaded. Because sometimes we're waiting for a lot of assets to download and finish its process before we even start doing changes. And some of those changes can be done parallelized. And in between the assets are downloaded, we can start processing some of that. So one of the tips that we have is try to hook up things to the DOM content loaded event instead of doing it to the load, because the load has to wait for all of the assets, everything to be rendered before it starts execution. DOM content loaded will start right after the DOM is parsed and put into service. And then initialize JavaScript on demand. And here is very important. Don't download everything that you think you're going to need. Try to break down all of your functionality in different files, and then as the user is going to get there, try to download those. Therefore, you're not going to have a hit on the browser having to parse a lot of code ahead of time, especially if these are features that are not that often used, and then you can just add it as the user will need it. So for those features that only the 20% of your user base is going to use or is going to make use of, try to postpone that as much as you can, and then don't take a hit on the rest of the experience that 80% of your users are gonna be doing. Also, JSON is always faster than XML for data. Why? Because it's native to JavaScript. The way it does the parsing and the way it do it, it's faster than processing a chunk of text that for JavaScript implementation has nothing to do with. JSON is a serialized object of JavaScript. XML is just a text representation of structures. So try to do JSON as much as you can. nowadays you can see that it has become a trend, but this has a reason behind, and it's because of the efficiency that you're gonna do. And at the same time, try to use native JSON methods. Most of the browsers have JSON implemented as part of their DOM, so try to make use of that because it's gonna be faster for whatever you write in JavaScript by hand. So don't overcomplicate things. Just go with the standard and try to do this in the most efficient way that you can. Also, and this is a hard thing, especially for geeks, use regular expressions sparingly. And this because all of the user expressions of the regular expressions are compiled. They're compiled for efficiency, but that also takes a hit on the process and the way it's done. And if you overcomplicate things and you use tons and tons of user regular expressions, all of them will go get compiled. So try to use them sound like you know what you're doing. There's been cases that we have seen pages that include up to 10,000 regular expressions, and at the end of the day only get to use 2. So try to make sure that you select those very carefully, that are things that are going to add value, and it's not just some cool thing that is going to just clink for the user, but that actually provides value, because they are very expensive to process. So you want to keep that in mind. Also, try to use seal and floor for your double precision floats as much as you can, especially for animations, because when you have something like this, right? When you have something like you're gonna be testing some value and then using that value for an animation, the browser actually is gonna use 12 to 49999 whatever the number is, as part of your animation. It's not gonna seal for you. They're gonna keep with the precision that you add. So rather than having 12, then put it on either 12 or 13 or 12.5. Therefore, that you're going to be able to minimize that hit, especially in the computational engine, in terms of using precision. You don't want to go all the way to this number unless it's needed. So make sure that you do that ahead of time. Also, and this is something that we were talking at the beginning of the presentation, try to minimize the way you interact with the DOM. Instead of doing changes straight to the DOM, try to batch all of those changes in one. Why? Because every time you make a change to the DOM, everything will have to be regenerated. The formatting, the blocking, the styling, the rendering. So try to put those hits in one big hit instead of doing it in a small chunks. Also, try to use the built-in methods for those things rather than building your own. So that way it's gonna be more efficient than if you will be crawling or implementing the methods yourself. Also, try to use selectors, the selectors API for collection access. These are implementations that are very fine-tuned, and it's gonna be easier than just having you going across the DOM doing the iteration. So this is going to work directly with the abstract syntax tree and all the different collections and structures that the compiler has created for you. So it's going to be more efficient than just doing it yourself. Try to keep that as well in mind. Moving along, we have inner HTML. Try to do that to construct your page so that the hits, again, is going to be simple to the page, and then this is just going to be a change in content rather than making a bigger hit in the term of making a change to the DOM. And also, like I said, try to batch all of your markup changes in one hit so that you will be able to implement those in a more efficient way than if you will do changes serially. And this also comes as an important point. Try to maintain a small, healthy DOM. There are many times, especially over time, as we have to do maintenance, that we're gonna be end up adding things. Try it as much as you can to keep it simple. Keep less levels of hierarchy as you can. Try to simplify the way the elements are overlap if they have to. Try to make it clean. Therefore, it's going to be easier to process, but also to render, calculate the formatting, the layout, and the blocking. Think of around 1,000 elements per page. More than that, it's too much. So That way, especially it's always good to think in band range. So try to put that 1000 elements cap. Now let's go back to principle number 6, and this is the last one, but probably one of the most important ones, and this is a call to action, or a call to attention. Know what your running application is doing. Try to know what's on your markup. Try to know what's on your JavaScript. Don't add things just to be cool, just because you find some piece of script online. Try to understand that. If you don't understand, better think twice on adding that to your page or your web application. One of the biggest things that running applications have is through two different methods, and this is the way pages will interact on their own. Either through a set timeout or set interval. Here you're gonna be a timeout, and then after some minutes or some seconds, it's gonna call back a function, and then it's gonna do something, and then it's gonna go to sleep. Or you can set an interval, and here you can do this on intervals of time. Again, having some set of time is gonna be doing this repeatedly. You wanna understand the way JavaScript timers works. Especially you wanna make sure that you can minimize and align those timers. Here we have three different timers, or three different threads running. We have one every 6 milliseconds, then we have one every 10 milliseconds, and then we have one every 50 milliseconds. You want to make sure, or if you want to try to align those timers, make sure that when the clock hits, then you will be able to execute several timers at once. So sometimes it's better to think if those timers that go along at 6 might be aligned to 10. So therefore you can have every 10 milliseconds and have the clock hit all of them at once. And then sometimes you can see if you can align those 10 milliseconds to the 50 milliseconds. So therefore you're aligning the execution to those elements in right on time, rather than having the clock going nuts and nuts, and that's important, especially in mobile sites, because you're going to be having a hit on the battery consumption in terms of this. Also, trying to align animations, especially if you're using a lot of these timers for animations, which is a very common use. Try to align those animations to the display frame rate, which is around 16.7 milliseconds, and that is around 60 frames per second. Also, if you want to be on mobile, you want to try to hit 30 frames per second. So try to do that aligned to those. Don't do it, if you do it say every 10 milliseconds, there is no chance that you're gonna be having the browser hit those frame rates. So try to rather extend those ones to the ones that are gonna hit. So for 60 frames per second, which is a very fast implementation or frame rate, especially for the eye, try to do it to 16.7. Less than that is going to be wasted computational time. And for mobile websites, or for mobile implementations, try to go for 33.4 milliseconds. This again is part of knowing what your browser is doing, knowing what your application is doing, and therefore you want to maximize the use of resources and do things in a conscious way and not just because. So this is it. This is what we had prepared for you. It's a lot of information. The slides are going to be available so that you can go at the pace of your own and then start seeing which of the best practices that we have talked today apply the most to your implementation, and make sure that you take your time. This is not going to take too much depending on the size of your web pages or your website, and especially if you have it well structured, it's not going to take that long to put in practice all of these tips and tricks that I taught you today. And the performance hit that you're going to have in your application, in your website, is going to be seen, it's going to be felt. So try to make sure that you take your time and do this proactively. There is nothing more regarding than seeing your site improve and to see it perform the way you planned to do it right from the beginning. So these are some of those things. Some of them are common sense, some other ones are not, especially some of the ones that break the common thinking about this kind of implementations, but go for it. So let's just recap a bit on what we see today. Quickly respond to network requests. Again, avoid redirections. Try to maximize the request time from the server. Try to use cache as much as you can. Minimize bytes downloaded. Cache locally, not only on the server, but try to make use of all of the different encodings that the browser has available for you. Try to use gzip whenever available. Efficiently structure static markup, and this goes along with the way that you do your markup. Try to improve the user experience by providing hints. Try to simplify your markup structure. Do this consciously as you want. Optimize media usage. Stick to standard images. Don't overkill the browser by downloading thousands of images. Try to use sprites as much as you can and do it yourself. Remember that it's important. Write fast JavaScript. Try to use obfuscators when you can and minimizing the size of your code, and pretty much improving the way it works. There are some tools available online as well that do some improvement in the way that you write your code. It's kind of like a pre-compiling of your code. And know what your application is doing. This is probably the most important one, especially I think it covers all of the five ahead of it. Try to know what it's doing. Try to understand and consciously make decisions based on how that is either going to add value or is going to have a hit on the performance of your applications. That is specifically important for web applications. So try to do it in a conscious way. So as I said, this is the second presentation. I hope you have gained a lot of knowledge out of this one. I know it is being a long and big presentation, but sometimes you have to put on things like this in order to improve the way things happen. So this is our second presentation. Next two, we're going to be focusing on more specific features. The next one is going to be blending your site with Windows 7. So once you have tuned up all of your application, then you can take it a step further and then make it closer to your Windows desktop, and that means making it behave as a Windows application. This is importantly nowadays that web applications and desktop applications are blurring in some of their extent. So this is a nice way and very simple way to provide an extra value to your clients. And we have the last one, which we're going to be talking about mobile and how you can take advantage from a lot of the things that you have seen so far on the phone with Internet Explorer 9 and Windows Phone 7 Mango. Okay, here are some additional resources for you to go and dig. This is the O'Reilly High Performance series. So pretty much is how you can write more efficient and faster JavaScript. So go get it. Again, remember Internet Explorer 9 and moving forward, it's focused on interpretable markup, interpretable JavaScript, so that the JavaScript that you write, you will only have to write it once and be sure that it's going to be executing in the same fashion, very fast, in all of the different modern browsers. Okay, so again, go try Internet Explorer 9 if you haven't. It's very fast, the user experience is great, and you're not gonna be wanting to move back to anything else. Keep on learning. There is here are some resources in terms of performance that you want to take a look at, and stay updated. Internet Explorer 9 is the first step for a new Internet Explorer age, and right now the team is working hard on Internet Explorer 10. There is already a platform preview, and what it's doing is building on top of the foundations of Internet Explorer 9 and just adding new features. And these are mostly focused on the HTML5 implementation. Just as features get more mature, then they're going to be implementing those. So make sure that you also stay updated on what's new on that end. Again, gentlemen and ladies, my name is Gilbert. I hope that you had fun and then you understand a lot of what's going on behind and how you can improve your applications. I hope you stick around for the other webcast, and I'll see you soon. Bye.